So Leibniz notation for the chain rule is a little funny. So how we would write it, we would write it like this. We would say that A is going to be equal to, so we're going to kind of break it up into the functions. So there's two functions in here. This is the first function, we evaluate it, and then we have a second function which is to raise the whatever this function output is to the 1/2 power, or just take the square root. So let's write out the functions like separately. So we'll say like the function A is like equal to the square root of something called b, right? But in this case, our b is 5x minus 1. So what I've done here is I've just written two separate functions. You input an x, and then you get a b value, and then from the b value you input in here and you get an a value. So the derivative of a, how they would ask us is they would say something like this. They would say derivative of a with respect to x. Okay, all that means is what's the derivative of a, in this case being this. So what's the derivative of this? And so like this would be equal to, this is like the funny part, you have to say like this, you have to say derivative of a with respect to b. So basically what's going on is that the numerator is always the guy on the left side, the denominator is just always the variable on the left side. So derivative of a times over the derivative of b times the derivative of b. What's on the right side? This guy is on the left side. And we can see that you can just cancel these out, and you will get that it's dA over dx. So this is like a definition for the chain rule. It's like you break up the functions and then you like multiply them, the outer, and this is like the out and the in. But this is just using Leibniz notation, which he's just a guy from a long time ago.